এই ভিডিওতে আমরা electrochemistry পড়ছি। So in this video we will discuss about the electrochemistry of Faraday's laws, two Faraday's laws, and electrode, and some mathematical problem on Faraday's laws. That's been first law of Faraday, second law of Faraday, what is the Coulomb, what is the Faraday, and ultimately some mathematical problem. Okay, so let us consider electrochemistry and electrolytic cells and electrolysis and Faraday's laws. So electrolytic cell and electrolysis. What is electrolytic cell? A cell which uses external source of voltage to bring about a chemical reaction is called electrolytic cell. It is an electrochemical process also. So, what is the uses of electrolytic cell? What is the use? The use is the electrochemical process is one of the greatest important aspects in the laboratory and the chemical industry also. So, for example, in the extraction of metals from ore. Features, what is the features? A mole positive charge is required to neutralize 1 mole of electron or 1 Faraday or 96500 Coulomb. Okay. 1 mole positive charge is required to neutralize 1 mole of electron, 1 Faraday. Okay. So mostly actually direct current is used as an external source of voltage. And example, Na plus electron equal to Na. Mg2 plus 2 electron equal to Mg. Cu2 plus 2 electron equal to Cu, and Al3 plus 3 electron equal to Al. Okay. This way. Quantitative aspects of electrolysis. Quantitative means we can measure the amount of material deposited on cathode or anode. That is quantity. Like 2 gram, 5 gram, 10 gram, 1000 ton, etc. is known as quantity, or the number of gram which can be deposited on cathode or anode, or we can prepare or we can extract metal, okay, in gram or ton or quintal, etc. So Michael Faraday was the first scientist who described the quantitative aspects of electrolysis in 1833 to 34. These are two laws. The first law of Faraday's electrolysis and second law of Faraday's electrolysis. So what is the first law of the electrolysis? The amount of substance that deposited or liberated at any electrode during electrolysis is proportional to the quantity of the electricity passing through the electrolytic solution. So what happened here? The amount of substance, that's mean amount means W. The amount of substance W that deposited on or liberated at any electrode. What is this? Any electrode, that is directly proportional to the quantity of the electricity, that's mean electricity Q, or I is the ampere passing through the electrolytic solution. if Q is the quantity of electricity in coulombs and Q equal to actually I into T. But I means, what is I? I means current and T means time. So is the IT. So Q equal to I into T. So it is the quantity of electricity passing through the electrolytic solution. So Q is the quantity of electrolytic solution in coulomb. M is the mass of substances, that's mean W. I have already discussed. So M proportional to W. M equal to E into Q, electrochemical equivalent. If the proportional sign is omitted, proportional sign, that's mean M proportional Q, then M equal to, that is, if it is capital E, there is no problem, or small e. Actually, by small e, it is denoted electron, so we can also use capital E into Q, where E is the electrochemical equivalent. Okay, E is the electrochemical equivalent. But Q equal to IT, where I means ampere, that is current, and T means time. Now, M equal to actually E into IT, okay, or CT. C means current. Then whatever. Whatever. See, with the equivalent weight, what is the difference of electrochemical equivalent and equivalent weight? If small e is the electrochemical equivalent, or if we say it is Z, if we say it is Z, then it will be better. Z equal to electrochemical equivalent equivalent. Okay. So, what is the equivalent weight? You know, equivalent weight is the amount of substance which can combine with 8 gram oxygen or 1 gram hydrogen or 35.5 gram chlorine. Is the equivalent weight. And what is the electrochemical equivalent? Firstly, you know that for one electron, charge is 1.602 into 10 to the power 19 coulomb. What is this? Charge of an electron equal to 1.602 into 10 to the power minus 19 coulomb. Then charge of 1 mole electron, 1 moles means 6.023 into 10 to the power 23 electron equal to, that's mean 1.602 into 10 to the power minus 19 into 6.023 into 10 to the power 23 equal to actually 96484, or it is nearly about 96500 coulomb. This 96500 coulomb is known as 1 Faraday. So 1 Faraday equal to 96500 coulomb. So 96500 coulomb actually 1 Faraday, which is actually the charge of 1 mole electron. Okay, charge of 1 mole electron. So M is equal to electrochemical equivalent into C into T. Then what is Z? Z equal to E into capital E divided by 96500 coulomb. What is this? This is actually when 1 Faraday electricity is passed through a solution, that's been 96500 coulomb, deposited E amount or equivalent amount of substances. So electrochemical equivalent, actually equivalent weight divided by charge of 1 mole electron, charge of 1 mole electron, that's been 96500 coulomb. So this is equal to Z or small e here. Is it okay? So E is the E by 96500 coulomb. E, capital E is the equivalent weight, while small e or Z is the electrochemical equivalent weight. This equation is first law of Faraday's electrolysis. And what is the second law? Second law is that if same quantity of electricity is passing through the different electrolytic solution, then the amount of substance deposited or liberated at electrodes during electrolysis is proportional to the chemical equivalent. So what is this? This is actually the same quantity of electricity is passing through the different electrolytic solution, then the amount of substance deposited or liberated at electrodes during the electrolysis is proportional to that chemical equivalent. So actually Q is directly proportional to E, capital E, that is chemical equivalent. Okay. So this is the picture. What is this? There are so many electrolytic cell. There is a cathode, anode. And what happened here? M1, let M1 and M2 mass of substances deposited in cathode or anode. Okay. And E1 and E2 is the equivalent weight. Then what happened? Then we can say M1 by M2 equal to E1 by E2. Actually, M or the mass is directly proportional to the equivalent weight. This is the second law. Now, there is a problem. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at the cathode? So, what is the reaction? At cathode reaction, Cu2 plus 2 electron equal to Cu. That's means copper will be deposited in the cathode. Okay, so at cathode reaction is this. And equivalent weight of copper is 31.6. That's mean atomic weight is 63.5 and valency of copper is 2. Then what happened? Equivalent weight will be 63.5 by 2. And now time is 10 minutes. That's mean 10 into 60 seconds. So time is 600 seconds. And current is I or C. It is 1.5 ampere. So time into current equal to coulomb or charge. So charge equal to 1.5 into 600, that is 900. And what will be the mass deposited on cathode? That is mass M equal to capital E into Q divided by 96500 coulomb. So this is equation. So the value will be this 0.29 gram. And second question is that two electrolytic cell contain 0.2 molar ferrous sulfate and 0.2 molar ferric chloride solution respectively are subjected to electrolysis. The ratio of weight of iron deposited in the two cells under the same time is 1:1 or 2:1 or 3:1 or 3:2. So what will be the answer? It will be 3:2. How? অর্থাৎ আমরা সলিউশন করতে পারি। We know W1 by W2 equal to E1 by E2. So according to Faraday's second law, the ratio of weight deposited is equal to the ratio of their chemical equivalent, that is E1 by E2. W1 by W2 equal to E1 by E2. So W of ferrous divided by W of ferric equal to chemical equivalent of ferrous divided by chemical equivalent of ferric. So this is the equation. Now what is the W or equivalent weight of iron 2? It is 56 by 2. Because why it is 56 by 2? Because this is the valency 2. So equivalent weight is the atomic weight divided by 2 and here atomic weight divided by 3. It is the equivalent weight. So 3:2. Number of coulombs required to deposit 5.4 gram of aluminum when the given electrode reaction is presented as. So number of coulombs required to deposit 5.4 gram of aluminum when the given electrode reaction is represented as. There is a 4 option. Okay. So what will be the answer? It will be 57900 coulomb. Okay, but how? The number of coulombs required to deposit at the gram, 5.4 gram. So W is the 5.4 gram. And what will be the equivalent weight of aluminum? It is 9, that is atomic weight is 27 and valence of aluminum it is 3. So it requires in coulomb, that is 96500 coulomb. It deposit 9 gram aluminum. So 9 gram aluminum deposited by 96500 coulomb. So 27, that's mean 27 is the atomic weight and equivalent weight is 9 gram. So 5.4 gram required 9 gram required 96500 coulomb, then 5.4 gram required for the. So 9 gram of aluminum deposited by 96500 coulomb, so 5.4 gram of, is it 5, that is this, okay. So this is the value. Next, according to second law of Faraday's electrolysis, the correct one is, what is the correct? If you do something, if you do the mathematical problem, then the law will be clear to you. Otherwise, the law will not clear for anyone. Okay. If you don't know how we can approach for the mathematical problem, if you can approach for the mathematical problem, then the law will be clear for everyone. So, according to second law of Faraday's electrolysis, the correct one is weight of hydrogen liberated divided by weight of chlorine liberated equal to equivalent weight of hydrogen divided by equivalent weight of chlorine, or mass of silver, mass of copper equal to equivalent of silver divided by equivalent weight of copper, or mass of silver divided by mass of copper equal to equivalent weight of copper divided by equivalent weight of silver. And fourth one is mass of hydrogen divided by mass of copper equal to equivalent weight of hydrogen divided by equivalent weight of copper. So what is the correct option? You already know that W1 by Wt equal to U1 by E2, you know. So there is no problem. So which one is the correct combination? Is only 2 and 4, or only 1 is correct, or 1, 2, 3 is correct, or 1, 2, 4 is correct? So what will be the value? 1 is correct, 2 is correct, because M1 by M2 equal to E1 by E2, and 4 is also correct because mass of hydrogen divided by mass of copper equal to equivalent weight of hydrogen divided by equivalent weight of copper. This is correct. So products of electrolysis. What will be the product of electrolysis? You know, electrolysis of water, then in cathode reaction there is a hydrogen formation, and in anode reaction there is a oxygen formation. Okay, like this. The products of electrolysis, it depends on nature of the electrolytes, nature of electrodes. Okay, the nature of electrolyte, various electrolytes on electrolysis give different products. It depends on condition also. Okay, so various electrolytes on electrolysis give different products. It depends on condition also. So electrode, it is two ways. It is two ways. Case one, if the electrode is inert, like platinum, gold, etc., it does not participate in the chemical reaction and thus acts only as the source or sink for the electrons. So we can say that if the electrode is inert, like platinum, gold, it does not participate in the chemical reaction and thus act only as a source of the sink for the electrodes. And in the case 2, the electrodes are reactive, they participate in the electrode reaction. Electrolytic cell, in electrolytic cell, cathode is negative and anode is positive. So, for electrolytic cell, anode is positive and cathode is negative. In cathode, oxidation takes place, and in anode, oxidation takes place, and cathode, reduction takes place. More E0 for oxidation get oxidized easily, and more reduction potential reduced easily. Okay, so more is the reduction potential get reduced easily. Decreasing order of oxidation potential, this is the order. Iodine is iodide. Okay, it's readily from iodine to iodide it will form. And what is the order? The iodine will be more oxidized than bromine, than chlorine, okay, than others. Increasing order of reduction potential, you know that in chemical activity series, gold, platinum, or some noble metals are in the lower side of that activity series. So they have higher reduction potential. So increasing order of reduction potential is that all metals more reactive than hydrogen, then less than 0. Okay, hydrogen is the 0 potential, reduction potential is 0 for hydrogen. Then what will be the order? This will be the order. Last one is gold. So copper, silver, gold, this is below the hydrogen. So it's a copper, silver, gold, mercury, platinum below the hydrogen, and their reduction potential is high. Oxidation potential of lithium is more and reduction potential is very low. That is, reduction potential of lithium is negative, and for reduction potential of copper, mercury, silver, platinum, gold is positive. Hydrogen is 0. For aqueous solution of salt, if the metal is less reactive than hydrogen, it will get deposited at cathode. Okay. If the metal is more reactive than hydrogen, hydrogen gas will be liberated at cathode. So for aqueous solution of salt, in aqueous solution of sulfate, nitrate, anions are not oxidized. Here water undergoes electrolysis to produce oxygen, and oxygen at anode and hydrogen is at cathode. Okay. For this electrolysis, electrochemical series is very useful. Okay. For fused sodium chloride, cathode and anode is platinum, and cathode reaction, it will form sodium in cathode and chlorine in anode. But in aqueous solution, it will be different. Okay. In cathode, hydrogen will be formed, and in anode, chlorine will be formed in aqueous solution of sodium chloride. But for fused sodium chloride, cathode reaction is this. That's mean sodium deposited in the cathode and chlorine deposited in the anode. Like this. So aqueous solution of copper solution, copper sulfate solution, that's mean in cathode copper will be deposited, but in anode oxygen will be deposited. So electrochemical series, the arrangement of various single electrodes in the increasing order of their standard reduction potential values is called electrochemical series. So whatever the arrangement of various single electrodes in the increasing order of their standard reduction potential values is called electrochemical series. And in the electrochemical series, in the upper position, it remains lithium plus or potassium plus calcium, etc. Then sodium. And in the below of the hydrogen, it will be copper, silver, gold, mercury, platinum, etc. So this is the order of the electrochemical series. Electrode system. Standard reduction potential, that is E0, which is known as actually standard reduction potential. E0 of cathode, E0 of anode, maybe it's no problem. Lithium plus lithium, it is minus 3.045. This is the reduction potential. And for K plus to K, that's when potassium plus to potassium, it will be minus 2.925. Okay. Calcium 2 plus to calcium, it will be minus 2.870. And zinc 2 plus to zinc, it will be minus 0.762. And hydrogen plus to hydrogen, it will be 0. Okay. And copper 2 plus to copper, it will be positive because it is copper in electrochemical series below the hydrogen. Okay, so it will be positive 0.337. So copper plus to copper, it will be plus 0.52. Ag plus to Ag, it will be 0.08. 0.8. So in this way, useful conclusion: a negative E0 means that the redox couple is stronger reducing agent than the H plus H2 couple. A positive E0 means that the redox couple is weaker reducing agent than H plus to H2 couple. Okay. The metal with higher negative potential displaces a metal with lower negative potential or positive potential from aqueous solution of the metal. That's mean zinc and copper sulfate, if you give a solution of copper sulfate solution, if you dip a zinc rod, then zinc sulfate will be formed and copper will be deposited or separated out. So this is the reaction. Because the higher oxidation potential of zinc than copper, then zinc will be oxidized and copper will be reduced. The metal above hydrogen displaces hydrogen from dilute acid, like sodium, zinc, potassium, calcium. They all can replace hydrogen from hydric acid. That's mean zinc plus sulfuric acid, zinc sulfate plus hydrogen. But copper can't displace hydrogen from sulfuric acid because copper is in below the hydrogen in activity series. Okay. So reduction potential of hydrogen is 0, but reduction potential of copper is positive, hence copper will be reduced fast. Okay. So sodium, zinc, etc. can displaces hydrogen from acid. So low reduction potential metal is stored in the high reduction potential solution. So we can say zinc sulfate solution stored in copper pot, but copper sulfate solution not stored in zinc pot. So there is a question: aqueous sodium chloride on electrolysis give dash at cathode and dash at anode. It is chlorine hydrogen. It is oxygen hydrogen, or it is hydrogen oxygen, or it is hydrogen chlorine. So which one is the correct? Hydrogen and chlorine. Because in cathode, since it is aqueous solution, then hydrogen will be deposited in the cathode and chlorine will be deposited in the anode. But if it is fused condition, then sodium in the cathode and chlorine in the anode. So this is the answer. Thank you for your patience.